I'm ready.
Okay, so we're collecting some data to do a specific heat calculation. And bear with me, it's kind of like a cooking show. I've got some of this done already to save us some time. The first thing I'm going to want to do is I'm trying to find the specific heat of this metal. And I've cheated already. I know what this metal is. The metal that we're going to be testing is tin. We're going to compare our data to the specific heat data that we get in a book or on the internet. So the first thing I need to do is find the mass of my metal. I've got it zeroed. I put this on the balance. And I'm going to record my mass. Okay. And then I'm also going to need to know how much water that I'm going to put this in. So I've got my insulated cups here. I'm going to put those on the balance and zero it out. And then I have enough water in here. I didn't have to be very specific when I was getting the water, because all I want to make sure is when the water is in these cups and I lower the metal in, that it's going to be totally submerged. So I'm going to add this water. Now it looks like 73.50 grams. Okay. Now I need to take the temperature of the hot water that I have boiling over here, because I've placed an exact replica of my metal in that water, and what I'm trying to do is get that metal really hot. I don't have a good way to take the temperature of a solid, but I know if that metal is in the boiling water long enough that that metal and that water are going to reach the same temperature. So if I know the temperature of the boiling water, I actually know the temperature of the metal as well. So I have that set up over here. I'm going to make sure I don't hit the hot plate, because that would really send that into orbit. And I'm going to wait till my temperature stabilizes, or calibrates, if you will. Okay, I'm going to go with about 96.7, because that's where it looked like things were going pretty calm. I also need to know the temperature of my cooler water. This is room temperature water. Notice my temperatures are in Celsius, okay? In the lab, we always use Celsius temperatures. Unless we're doing gas laws, then we use Kelvin. But that's later in the semester, so we'll just stick with Celsius for right now. Again, we're going to let that equilibrate. Looks like, ooh, oh, there's motion. I know. So exciting. We'll go with 25.7. And now what we're going to do is we're going to take the metal that's in this hot water and put it into the room temperature water. Let's talk about what's going to go on there. The temperature of the metal is going to go down, because the heat from the metal is going to go into the cooler water. The cooler water's temperature is going to go up, because the heat is being transferred from the metal into the cooler water. Eventually, they're going to hit what we call an equilibrium. They'll both be the same temperature. So let's do that now. I've got a lid here just to make sure we don't let too much heat escape. And we're over. Put that in there. Swirl it around a bit to kind of help everything reach its temperature. Then I'm going to have to go in a different way. It's good in theory, right? But I'm going to make sure I'm in the water, not touching the metal. We can see over here that the temperature is climbing. Wait till we equilibrate. We're going to go with 28.5. All right, now we have all the data we need, and I will take you into our next step to do our calculations.